let's do a TDD kata. The name of this kata that I would like to do is PrimeFactor, and we're going to use it to do an example of Spock unit tests and the Gradle build environment. This is the Intellij IDE, and this is the beginning of a new project. I'm going to try to do this in real time. And at some points, the tool is going to try to download additional pieces and put things in place. So there will be some pausing in there. Bear with me, or certainly jump ahead a few seconds at a time when that happens. So and we're going to let it go through its process and pull its stuff down. Gradle is building stuff down here. You see it's got the progress bar. It's building its parts and pieces and everything. And you can see over here on the right that it's getting the other parts that it wants to have. It's set up our directory structure over here, so we have our main and our test, and it already knows that we're going to have both Groovy and Java available to us. Not certainly why I don't need Groovy up here and I don't need Java down there, but who am I to argue with how they want to set things up? One of the first things I'm noticing here is that in the build Gradle, it's suggesting that maybe we might want to upgrade from 305 to 308. So I'll certainly go ahead and allow it to do that. And then we're going to add the Spock framework that corresponds to the Groovy. And now that we got our Spock, we got our Groovy, we're not using any of JUnit, so we can delete those out of there, and that should be fine. We shouldn't need to see the build Gradle file anymore, so let's close that and get it out of our way. Now, normally what I would do is start here, create a new object, but I'm going to break my own rules and I'm going to start over here and let it actually create the original Java class. And the reason I want to do that is because one of the nice tools that IntelliJ provides is this create test, which is nice because it's going to allow me to have choices of how I do my tests, but we're going to do, we're going to say we want to do Spock. We're going to let it fix the fact that even though we chose and put Spock in the build, it didn't actually pull all that it needed to do. That's fixing it, and now we see that there's no red on the Spock there. And we're going to let us do a setup. There's really no need for a teardown in this case, and we're just going to let it go, make sure that it's putting it in the test Groovy, and we say OK. So one of the nice things that you get with that is right now we can say we can create our object ahead of time, and then we can initialize it every time a test runs. So we would say PrimeFactor equals new, and that setup will allow each time that we do a new test to actually start with a clean object that doesn't have any state or anything saved from before. Now normally I would write a test for each step of the way, right? So in your prime factor, you're going to say, okay, if we pass in a 0 or if we pass in a 1, neither of those counts and has anything, so we're going to get back a list that is empty. However, what I found that I can do in Spock is I can set up a list, well, not a list, a table. I can set up a table of results, and so each test is actually just going to be an entry into that table. So we're only going to actually have one test here. So rather than name this test something like, should show empty list for 1 or 0, I'm kind of going to short circuit this and just say should return list of factors for given input. Okay, it almost feels like cheating at this point, but that's okay. So normally, when you would do these types of tests, well, not the type of tests, but normally when you would do a test using um, Groovy and Spock, you would say, given and when and then, and you'd set up some values in here and you'd set up your differences there, and then your then would be where you'd actually have your testing. Um, because I'm doing this, I really don't need I don't need anything given, and I already have my setup for doing some of that stuff. But instead, we're going to do this a little differently. We're going to say expect, and we're going to do a where. All right, so all of these, they're not important. So our expectation is where we set up what we're going to do in the table. So what we're going to say is result, and we're going to test that equals prime factor, and we're going to call it, sounds cool, and we're going to put the input in here. Now there's no real necessary reason why result and input should be set up here in capital letters or whatever, but it makes them stand out a little bit when you put them in the table, so they kind of feel to me like table headers. But certainly if you're more comfortable putting them in normal lowercase, that would be fine. And so we already decided that we're going to say when we input 0 or if we input 1, we want to see an empty list come back. And that's done with list of and list of. So in this case, we have our test, and we almost have a failure in the fact that Factorize hasn't been written yet. And so we'll do an alt enter here, and we're going to create the method Factorize in the prime factor. And what we say we want back is a list of integers, and we're going to pass in an integer, and we're going to call it input. And we have now written, well, no, we have one thing here that's still all in red, so we'll go ahead and import the class for list. And there we go, we have our list, we have no more red, and we don't have any red in there, so we can certainly go here to Gradle, go to tasks, verification, and this is where you run your tests from. Now, once we've run the test, you'll see up the top here, it's actually creating a run configuration. And so that's going to allow us to ignore all of the Gradle stuff and simply rerun our tests over here from the arrow that's on this. So that gives us a little more room. We don't need to see that screen anymore. So now we see that we have failures because 0 and 1, we're expecting them to return an empty list, but in both cases, we're getting back a null. And so congratulations, we've written our first failing test. So now that we've written a failing test, the rules say we can actually write just enough production code to make the test pass. And we can do list of, and it's empty. And when we run our test, we should see that our tests are going to finally pass. There we got 2 passing tests. Now, at this point, there's nothing else I really care to see over here. So we're going to make that small. And we have our tests on one side. And if I take the actual code, this is the code. The tests are actually more interesting than the code. So we'll drag the code tab over to the right. And now we'll have the code over here. So, as I was saying before, all I have to do from my test now is add a new line. And we're going to say, if we pass in a 2, we want to see a list of 2 because the only factors of 2 are 2 and 1 doesn't count as a prime. So we put that in there. When we get our test to fail, we see that 2 fails because it's returning an empty list. Where's our 2 here? All right, we're getting an empty list back, and we want a 2. So come back to our code, and we're going to say, let's start with an if, right? If input is greater than or equal to 2, and we're going to return well, let's say we're going to return list of input. Okay, and so if we get an item in here that's greater than or equal to 2, we're going to put that in a list and return that. And that is the absolute simplest thing we can do to make this test pass. Now, in theory, I could actually do 3, and I believe that test would also pass. However, I don't like what we're looking at because, we've gone from red to green. We've certainly got green, but now let's do a little refactoring because this is kind of ugly. We have a return here and we have a return here, and that seems a little bit like something that would be repetitious. So, in the idea of not repeating ourselves, let's create a return variable and work with a return variable. And we're going to say that we want a list of integers. And we're going to say, we're going to call it factor list. And we're going to initialize it to a new array list. And then instead of returning the list of input, let's simply factor list dot add input. And then down here, no reason to return a list on its own. We'll return the factor list. And because we've written tests, we can see that this refactoring works. We've still passed our test, right? So this isn't a big change. We've got a we've got a nice clean code because we have, one way in, one way out. We got one return, and we're dealing with an actual variable, which is kind of what we really want to do anyway. So now it's time to write another test. So another test, we're going to look at the number 4. And a number 4 would give us back prime factors of 2 and 2. See that it fails because what we're going to get back is probably a 4, right? So if we go here, we click on that. We're going to say, it says, hey, for the input, we're getting back 4, and that's not equal to 2 and 2. So now, if we come in here and we look at this code, it was kind of silly to just do that, right? We kind of want to put something in there, but let's say, well, let's try this. So if input is greater than or equal to 2, and we're going to say if input mod 2 is equal to 0. So let's say if we have an even number at this point, we should put a 2 into the factor list. And then let's say we get that out of there, and so we say input is equal to input divided by 2, right? So we took the factor out, and then we're gonna reduce input by that. Now if we get out of the if and the input is still greater than 2, we're gonna go back to what we've already written and put that in there. This should be simple enough to allow our stuff to pass here. Let's see if we did that. Hooray, because we got 2 and 2. Now, if we go with a 5, we could do 5, but 5 should actually return 5, right? That's probably not interesting at this point because I think we already know how that's going to come out. But let's do the test. Terrific. So let's do the test for 6. And what should 6 return? 2 and 3. All right. So we let this run. And look at that. Amazingly enough, we still haven't written a failing test. I say, oops. If we do 7, we should get a list that just has 7 in it. Is that going to work? I think it should work in a nice boring way. And then now, what happens to 8? 8 is 2 and 2 and 2, right? 2 times 2 is 4, 2 times 4 is 8. And that probably will not pass this test. So let's see what that does. Get down to the bottom, click on that one. We see that what we're getting back is a 2 and a 4 when we really wanted 2 and 2 and 2. So that's not satisfied. So we now have a failing test again. So now it's time to go back and look at our code and say, well, let's see what can we do? What can we do to make this work? So in this particular case, one of the simplest things we can do, and this is where the magic begins, is I could just take the if and change it into a while. Okay. This is the beauty of TDD when you actually see things progress, right? So you went from an if, you changed it to a while. Now this is going to take care of this as long as that's the case. So if we run this test now, very simple change. Try to keep the changes to a minimum. All the tests pass. Look at that. We got an 8. Now, this is pretty. It seems to work out all right. But you know, I've got a lot of 2's here. So do we really think that that's good? I don't know. Let's say that this is a bad idea to have magic numbers in here. So we will refactor by introducing a variable. And we'll let it do the 3 instances. So we're going to call this the divisor. All right. And so now we have this simple variable. And you know what? Let's take it up here and we'll do it there too. All right. So now we have the same code, but we've removed the magic numbers from here, right? This is still based on what the minimum factor can be, but this one is based on what we're actually doing, right? We're going to take the input, we're going to divide it by something as many times as it takes, and we're going to reduce input by that. So this is a refactor phase, and we can keep refactoring, but we have our tests in place that will keep us knowing that yes, what we did to refactor did not break anything. All of our other cases still work, so we're doing okay. So now I think it's time that we introduce another test. So let's see what happens when we get up to 9. So the factorization for 9 is 3 times 3. And when we run this test, we should see a failure. And we do see a failure because we're going to get 9 back. We're getting a list that includes 9. So no 2's, no nothing else. It thinks that 9 is, according to our logic, it thinks that 9 is prime. Well, here's where we get another real pretty change. So we changed our if to a while here because we wanted to do this for all of the times that it would take to reduce the value down. In this case, we were doing an if, but we want to actually increase the divisor, right? Because we've done 2 and we've exhausted the 2 for how many ever times it takes to be the 2. But we want to increase that and say, hey, let's see if it's divisible by 3 and 5 and 7 and on up. So in order to do that, we're going to change our if into a 4. But we'll start up here, right? So we're going to say for int divisor equals 2. And then we're going to bring up our if, and we can just delete the delete. Now, we're going to do this as long as the input is greater than or equal to the divisor. And then we're going to, each time, increment the divisor. So it's going to go through as 2, and when it's done, it's going to go. And when it finally gets to where the divisor and the input, when they cross over and is less than the divisor, whichever way you want to look at it, it'll stop, and then we're going to drop through. That should simply be enough. To let our test pass. And just to see, let's try something big. Oops, did I not put the big one in here? All right, so rather than actually doing the calculations out, just put all the same numbers there as I have here. So if these are all primes and they're in the right order, this should be all right on this side. And 2s, 3s, 11s, 17, 53. All that should be good. The last thing to check is 1, 2, 3, 4, 5, 6, 7, 8, 9. Interestingly enough, I didn't think we should get away with this for more than 10 in list of, but I think I've used it and it worked, and it certainly did. So there we go. We have a relatively large number, 85, 80, whatever that number is right there. And it works, and we have our thing. This could be a little further refactored now, in that one of the things that happens is there's really no reason after the first time through to divide or to increment the divisor by 1 each time. You have to increment it from 2 to 3, but there's no reason to ever go to 4 because you've already done 2, so all of those are good. So is we can add an increment in here, and instead of saying plus plus divisor, we can say divisor plus equals increment, and then we can say increment equals 2. I don't know, does this bias a whole lot? I don't know, but it's certainly one of those things that's just fun to show as, hey, I know this is a little more efficient, and we're going to have a fewer times through, half the number of times, right, through the for loop, so that's got to be a little bit better. And in testing that, the tests show that we still pass. Let me know how you like this kata, and I challenge you to try this yourself. You don't have to use Spock. You can certainly use JUnit or any other unit testing that you like, and you don't have to use the table, right? You can certainly write an individual test for each one and just keep writing new tests, but do the kata. They are going to reinforce the process and make it all part of your muscle memory.